Hello students, today we will discuss about the interior angles and exterior angles, or what is the sum of total interior angles of a given polygon and what is the sum of exterior angles of a given n-sided polygon. So first of all, if in triangle this, if I say this one is interior, this is also interior, and this one is also interior, and if I extend this side here, so the angle formed by the extended side and the adjacent side will form the exterior angle, that means this one. Or if I extend this, then this angle. If I extend this side, then this angle, right? So what will be the sum of the interior and exterior angles of a polygon? So we have a general formula for sum of interior angles of a n-sided polygon, that is n minus 2 into 180. Now to check this thing, put n is equals to 3. So n is equals to 3 for a triangle. So 3 minus 3 is 0 into 180. Sorry, 3 minus 2 is 1. Really sorry. 3 minus 2 is 1 into 180 degrees, and which is exactly equals to the sum of interior angles of a triangle. Now put n is equals to 4 for a quadrilateral. So 4 minus 2 times 180, right? 4 minus 2 is 2 times 180 is equals to 360. So yes, the formula holds right for each and every polygon. So by this formula you can easily find what is the sum of interior angles of a regular polygon. Now talking about exterior angle, the sum of exterior angle of any type of polygon is 360 degree, right? If whether it is a 10-sided polygon or 100-sided polygon or 3-sided polygon, the sum of exterior angles will be 360 degrees only. We are talking about a regular polygon here. Now if you want to find the number of sides of that regular polygon, then you will have been given one exterior angle of a regular polygon, right? Or simply what you can do is you can write number of sides will be equals to 360 degree divided by exterior angle of a regular polygon. We have just changed this formula. So now moving on to next, that is types of quadrilateral. So first of all, quadrilateral is basically divided into three parts, that is a parallelogram, trapezium, and a kite. All right, so first let us get one point about all these three types of quadrilaterals. First one, in a parallelogram, opposite sides are equal. Opposite sides are parallel. If both the pair of opposite sides are parallel, then the quadrilateral will be a parallelogram. Next, talking about trapezium. Opposite sides are parallel. Only one pair of opposite sides is parallel. In trapezium also we will have some kinds, but we don't study it here. Now let's talk about kite. So in kite, the adjacent sides are equal, right? No two sides are parallel, but adjacent sides are equal. Now let's talk about types of parallelograms. We have three types, that is rhombus, rectangle and square, right? So rhombus, let's start with rectangle. Rectangle is a type of parallelogram, right? Rectangle is a type of parallelogram in which opposite sides are equal and parallel, and one thing that is not there in parallelogram but in rectangle is all the angles are equal. All the angles of a rectangle are equal, right? In rest, each and every property of rectangle is same as the property of parallelogram, except that all the angles are equal of rectangle. Now next type of parallelogram is our square. So square can be stated as it is a type of rectangle having all sides equal. It is a type of rectangle having all sides equal. That means square will have all the properties of rectangle, and as the rectangle is having all the properties of parallelogram, so square will also have all the properties of parallelogram as well as rectangle, right? Now third type is rhombus. So in rhombus we have all sides equal. First thing, the diagonals of the rhombus, they bisect each other at right angle. Okay, so uh, in this triangle we can apply Pythagoras theorem easily to find the value of its bisected diagonals or its length of the side. Now here are some properties. This we will discuss in the next lecture. We'll start with the property of kite, but before that let me tell you about isosceles trapezium, right? Isosceles trapezium, what is an isosceles trapezium? In this trapezium, let us name this trapezium as A, B, C, D. These trapezium, AB is parallel to DC, right? And if AD becomes equals to BC, then this kind of parallelogram is called isosceles trapezium, right? So next video will completely discuss about the properties, or maybe through PDFs.